Good afternoon, Robert.
How are you?
Pleasure to have you at Multicore World for the first time, hopefully the first of many. But you have a vast career founding companies in Silicon Valley for a long time in the US. Suddenly you are in Multicore World. What brought you here? What makes this little event interesting for you?
Well, that's easy because you invited me, right? But I am glad that I came because I've learned a tremendous amount from some very able people here. And I certainly appreciate that, right? In a sense, I'm on the other side of the fence because it's not multi-core that I'm promoting, but in fact, moving functionality into the memory rather than the processor, right? And that's been a very, that PIM technology has been very unsuccessful over the last 50 years.
So that's a specific technology that you are starting, or it's a continuation of your previous work?
From the moment that memory transformed from core memory, which is weaving technology, to semiconductor memory, which is printing technology, people proposed various PIM technologies, processing in memory, right? Some of my peers at the University of Illinois actually proposed logic per track, processing per track. In other words, having little processors all the way around a disk drive, right? Which is an extreme form of exactly the same thing, right?
That's on the times of Micron.
That's on a time frame of 1975 to probably the end of the century, right? Every time you did that, Intel would come out with a new processor that was twice as fast as the one before. And just bear in mind how spectacular that improvement was, because over a 30-year period, say 1975 to 2005, 30 years, it doubled every 18 months, which means it doubled 20 times. That's 1 million times, right? In fact, from the beginning of the computer era to today, it's about 1 billion times, which is 2 to the 30.
It's hard to think about.
There is, I don't think, no other artifact of humanity that has seen such spectacular increase sustained over multiple lifetimes. Right?
And still functioning reasonably acceptable.
Yes, and probably going to see the same improvements again in the next 10, 20, maybe 50 years, right?
Now, you have a vision for New Zealand as taking advantage of certain developments that you are pushing. Could you give us a headline on that?
Right. The fundamentals are that the fabrication business and the design business have split apart, right? You no longer need to spend $500 billion on a fab, and they are very expensive, in order to be a chip house. Xilinx, for example, is completely fabless, right? And they build one of the FPGAs, right? There's no reason. So the design functionality is now almost a purely intellectual exercise. There's no reason that New Zealand shouldn't participate in that. We have or had a pretty good education system. We've got a lot of educated people. And there's no reason, in my view, that we shouldn't contribute to that, because we don't have to spend the inordinate amounts of money that, frankly, New Zealand couldn't afford to do, right?
But still someone has to pay for that. And I don't see the New Zealand government particularly not even understanding what could be done on that field.
I don't generally favor government funding for anything, simply because it cannot pursue simultaneously multiple threads of development.
Well, the CHIPS Act is doing an interesting job.
Maybe, right. I mean, the CHIPS Act was really designed to defend Micron, is what it was designed for, right? I don't think that the CHIPS Act itself has really pushed any progress that wouldn't have happened anyway, right? And the issue is that with absent government funding, it'll develop, and those tentacles will run in all sorts of directions, and one of them will be much more successful than the other. And that's the progress that we cannot afford to lose, right? And that's why I generally don't like government funding, right? And I don't think in the design space we need a lot of government funding, is frankly my opinion, right? Now, if we were turning around talking about building a fab, well, that's a different issue.
Yeah, well, someone could argue that the CHIPS Act is a real estate act.
It was, and indeed the money was used by Micron to build a facility up in the Northeast, right? So it's
And bring TSMC into Arizona.
And bring TSMC into Arizona, which I think is a good defensive move anyway, but that's what it's used for, and that's what it should be used for, although I'm personally opposed to it. Right?
As a side aside, have you heard the name Dave Jagger? It's a person who born and educated in Christchurch, who went to design the first number of chips of ARM and become the one. Well, he founded the ARM's facility in Texas later, and he was educated at the University of Canterbury. He lives 5 minutes out of the airport, retired, of course.
Yes.
So, I mean, that sustains your principle of there is no reason why the design. Exactly. Exactly. So, what are we going to do then?
Well, I think, my ideas may have merit or not, and I certainly think that would be a foundation for some fairly radical developments which would migrate functionality away from the processors towards the memory, which I see as making dramatic improvements, orders of magnitude at least, maybe orders of 2 magnitude improvement in performance. And also diversifying it out in a way that in many ways recapitulates the way nature does it. So I suppose everybody says that, but
how do you think Multicore World helping them? Because otherwise we need to stop the interview and get back to work.
Well, yes, I should, right? But it's raining, so we can continue the interview, right? So, well, I think it being exposed to a lot of the very capable people who have been here has been extraordinarily valuable. As you say, you put yourself in front of those people, and they may say this is at least worth looking into, right? So
you got that feedback from the audience.
I got that feedback from several participants. Yes, so I was quite encouraged by that. Right.
Fantastic. Well, thank you very much, and hope to see you next time.